Millau Viaduct, Aveyron, France, about $394 million. A ribbon of steel and concrete sails above the Tarn. Height, grace, wind-cutting efficiency paid for. 7 pylons step across the valley. The tallest pier rises higher than the Eiffel Tower's summit above sea level. A streamlined steel deck shaped like an aircraft wing. It slips through crosswinds as stay cables share the load. Strength without bulk. Every line serves a purpose. Foundations dive deep into Jurassic limestone. High-strength concrete piers taper to cut wind drag. Above, precision steelwork keeps the deck slender. Stay cables fan from needle-thin masts pinning the roadway. From this height, the Tarn Valley falls away, clouds at your feet. Minimalism by necessity. Building in the clouds demanded nerve. Budgets sank into deep foundations and complex geology. Crews battled violent winds and sudden weather shifts. The elegance you see is structure doing only what it must. From serene France, we travel to New York. Next, a titan of steel. Verrazzano Narrows Bridge, New York. Built in 1964 for $320 million. In today's dollars, several billions. A gateway of steel. Between Staten Island and Brooklyn. Built for a metropolis. Its scale is immense. 2 towers stride into the harbor, their legs sunk to bedrock through water and silt. They carry the main cables. Each is a river of wire, over 100,000 strands compacted into strength. A heavy plate steel deck below. It carries a relentless flow of traffic. Watch both decks in motion. The double-deck roadway breathes with temperature. Expansion grants inches in summer, and grace in winter as the steel contracts. Engineered to turn ocean winds and tidal pull into a daily effortless crossing. Now, Japan's quake-defying marvel. A span built to survive the Earth itself. Japan's Akashi Kaikyo Bridge, the world's longest suspension span. It strides the Akashi Strait, a fierce seismic corridor. 2 steel towers, anchor suspension cables as wide as a human torso. On deep caissons, pendulum-type dampers wait to absorb violent tremors. Flexible joints and aerodynamic deck ribs let it bend, sway, and bleed energy. Built for typhoons, winds near 290 kilometers per hour, and for earthquakes up to magnitude 8.5. Resilience at a price. About 500 billion yen. Decades of research and full-scale testing. A record span between Kobe and Awaji, tuned like a giant instrument. After the 1995 Kobe quake shifted the shores, engineers lengthened the span and finished the bridge. Resilience written into steel. To one that redefines distance itself. Ahead, a bridge longer than some small nations. Danyang-Kunshan Grand Bridge, Jiangsu, China. Multi-billion, high-speed rail viaduct. Part of the Beijing-Shanghai line. Not one bridge, but a new idea of distance. Pillars pace the delta, lifting trains over canals, fields, and towns. For 164 kilometers, a continuous viaduct runs level across soft ground. Prefabricated box segments arrive like clockwork. Gantries place each span. Factory rhythm on site. Lift, align, lock, repeat. Standardized piers and joints repeat with millimeter precision to the horizon. The sameness is strategy. Speed, control, predictable cost. This is mass production applied to landscape. Repetition becomes power. The same molds, the same rebar, the same precision, thousands of times. On the flat horizon, trains skim above water and farmland. In the Yangtze River Delta, its length feels unreal. 164 kilometers of continuity. Cost follows scale. Concrete by the oceanful, steel by the shipload, time shaved by design. Assembly line methods cut months. Materials and logistics dominated the budget. Next, an American icon facing modern costs. Golden Gate Bridge, San Francisco, USA. Built for $35 million in 1937. A flame of international orange between headlands and Pacific fog. Art Deco towers rake the sky. Main cables trace twin horizons. Twin pylons anchor the span above the strait. Steel plates, millions of rivets. Purposeful lines. Sway bracing reconciles beauty with motion. Heavy suspension cables carry the roadway. Thick cables, painted international orange, carry the roadway below. A deep stiffening truss provides stability. Beneath the deck, that truss resists crosswinds and vortex shedding. Fog rolls in, leaving only the towers adrift. Decades later, seismic upgrades quietly armor the classic. The original $35 million has grown, billions spent to preserve and protect. An icon kept alive, and nearby, a bay crossing whose costs would spiral. San Francisco-Oakland Bay Bridge, new eastern span, about $6.4 billion. Two bridges share one name. The bill was paid by reinvention. A self-anchored suspension concept defines the new span. The Bay Bridge's east end was rebuilt for resilience and reach. The new eastern span stands apart. A self-anchored suspension design drapes its cable around the deck itself, structure biting its tail, the only one of its kind at this scale. A single white tower leans into the bay. Massive deck-level anchorage closes the cable loop. That sculpted tower balances forces with precision. Orthotropic steel panels trade weight for stiffness. Cranes, welds, and inspections. Complex work. Archival scenes. Strands pulled to form the single main cable. Delays and debates drove roughly $6.5 billion in overruns. Delays, debates, and details cost years, but the result is a resilient artery built for the next century. Now, India's modern fast-build roadway. Atal Setu, Mumbai Trans-Harbour Link, Mumbai, India, cost around 17,800 crore rupees, roughly $2.2 billion. A silver runway across the Arabian Sea, a fast new lifeline for Mumbai. Long box girder segments leap from pier to pier, launched by towering gantries. Precast precision shortens risk. Repetition shortens time. Slender marine foundations thread tides and monsoon windows. Logistics set the choreography. Built for speed, the link trades distance for minutes. On site, towering gantries place segment after segment with factory accuracy. Sea and shore logistics drove the schedule and the cost. It rewrites the region's map. Faster commutes, wider markets, new possibilities. Next, Turkey's record suspension span. Çanakkale 1915 Bridge, Çanakkale, Turkey. About 2.5 billion euros. Europe and Asia shake hands across the Dardanelles. Spanning the historic Dardanelles Strait, this is Turkey's Çanakkale 1915 Bridge. Towers painted in national red rise higher than many skyscrapers. It was built to make a statement. Monumental pylons, taller than the Eiffel Tower. The world's longest main suspension span. Those towers carry cables for that record span. Heavy suspension cables hold the deck. Streamlined box girders slice sea winds. A slim, aerodynamic deck, box girders and wind fairings cuts through the strait's fierce gusts. Cables, sockets, and bearings tuned to micrometers. Breaking records is costly. Precision and specialized materials consumed time and treasure. Part passage, part proclamation. The bridge turns history's strait into tomorrow's shortcut. Up next, India's sky-high rail bridge. Chenab Rail Bridge, Jammu and Kashmir, India. Costs near 1,500 crore rupees, around $180 to $200 million. A rail line hung above thunder. A steel arch leaps between sheer cliffs. Wind and altitude test every bolt. From the crown, steel trusses march outward. They carry track and heavy trains. Concrete pylons pin the ribs into rock. Cables and cranes once danced over a void to join the ribs. Assembly across the gorge demanded precision geometry. Every member placed to tame wind and seismic force. In this canyon, geometry is survival. The terrain is brutal. Height, weather, logistics. Each lift and weld planned to the minute. The price buys certainty. Strength over the Chenab. Now, the grandest and costliest maritime link ever conceived. Hong Kong-Zhuhai-Macau Bridge System, Pearl River Delta, China. About $127 billion, nearly $19 billion, not one bridge, but a sea-spanning network. Bridges pour over the water and tunnels cross beneath the sea. Artificial islands rise like engineered atolls. Long aerials reveal a continuous deck. The scale is almost beyond comprehension. A line of infrastructure stretching to the horizon. Islands connect bridge and tunnel. Massive artificial islands reclaimed from the sea serve as portals. The immersed tube tunnel entrance is visible. Here, the roadway dives below, into stitched segments built inside cofferdams. Massive causeways and giant cofferdams. Immersed tube sections were assembled and sealed on the seabed. It becomes a city on the water. Reclamation by the megaton, logistics by the tide, billions spent to shape the sea. 55 kilometers end to end. Coordination across borders and years. Underwater tunneling and marine challenges. Shipping lanes and typhoons demanded precise choreography. Environmental scrutiny, complex logistics, and a decade-long timeline. All to knit Hong Kong, Zhuhai, and Macau together. Cost mirrors ambition, materials by the megaton, precision by the millimeter. From a simple crossing to a system that connects entire regions. The longest of its kind, and among the costliest. The scale, the islands, the tunnel, marine engineering at its peak. 3 cities, 1 horizon.